Good morning, Year 4, and here is your maths lesson for Friday, the 22nd of January. You have been doing brilliantly with all your multiplication work so far, and this is lesson 5, which is recalling and using multiplication facts for the 12 times table. Again, both myself, Mrs. Cross, and Mrs. Plews were really impressed with the maths work that you sent us yesterday. These are tricky times tables, but you are seeming to get the hang of them really well. So hopefully you won't find this too tricky. Okay, let's get started. Can you please show me a multiplication fact for the 12 times table? Can you show me another and another? So just before I set you off, I'm going to use this baker's dozen from the pictures I showed you yesterday, and I will draw or drag out, because it's easier for me on the computer, 4 lots of 12. So you can see that there are 12 pieces of bread, bats, whatever you want to call them, and I've drawn 4 groups of them. What I can then do at the side is write that I am representing 4 times 12, and I can swap those around, 12 times 4. And if you can challenge yourself to work out the answer as well, so I know that this one is 48, and that one would therefore also be 48. Oops, you can then show me the division fact as well if you do want to challenge yourself. So I would show 48 divided by 12 is 4, and 48 divided by 4 is 12. And again, it's a lot quicker for me to say than to actually write, but hopefully you're following that. Please pause the video here and off you go, having a go, showing me 2 or 3 different versions of that. Good luck. Okay, well done for having a go at that. I'm sure your pictures are great, and like I've said before, you don't have to just do the pictures that I have at the side. You could do any representation or any pictorial version as long as it shows 12 of something. Okay. The 100 square then, let's just remind ourselves of how we work out those 12 times table. Again, it's slightly tricky because my 100 square rightly only goes to 100, but I'm going to be able to pop those other ones slightly below. So I'm going to start with my 1 times 12, and I'm going to start in my yellow for today. 1 times 12 is 12. And if I know 1 times 12, then I know 2 times 12 because I double it. So double 2 is 4, double the 1 or the 10 is 20. So I can pop my next yellow counter on the 24. Then if I know 2 times 4, then I know, not 2 times 4, 2 times 12. Then I know 4 times 12 because I double. So again, I double the 4 in the 1s column to 8 and double the 2 in the 10s column to be 40. So 48. Can't see too much of a pattern at the moment, but we may be able to see one soon. Then if I know 4 times 12, I can double again to know 8 times 12. So I'm going to double my 8, which is 16. So I'm going to carry that one mentally in my head. Double 4 is 8, so that would be 96. So I've just got to scroll down slightly. There we go, and I can just about pop that one on 96. Okay. Next one then, I've done my 1, 2, 4 and 8. I'm now going to go to my 10. So 10 times 12 would be 120. So of course I don't have this on my grid at the moment, but 100 is here. 110 would be just below it. So 120 is just below that. Okay, so if I know 10 times 12, I know 5 times 12, and I can half it. So I can pop that one there on 60. Okay, scrolling back up slightly. If I know 1 times 12, then I know 2 times 12. And if I know those 2, I can double them. What I can also see is a pattern emerging. So if you go along 2 and down 1, adding on that 12, I can pop in my blue colour on my 36 by adding them. So I've got a long 2 and down 1, and you can now see this diagonal starting to appear. If I know 3 times 12, then I know 6 times 12 because I can double it. So I'm going to be doubling 6 to get to 2 or 12, so 2 in my 1s, and carrying that 1. Double 3 is 6, so it will give me an answer of 72. Okay, not quite in that diagonal pattern, but hopefully again, some of the others will start to see that. So if I know 6 times 12, then I know 12 times 12 because I double that. And I'm going to actually have to scroll down even more and probably extend that just a little bit more so I've got more space, because double 2 is 4 and double 7 or 70 is 14 or 140. So I'm looking at 144. So my 94 would be here, 114, 124, which should be in the same row-ish as that red one, 134, one below, 144 further below that. And again, you are just going to have to imagine where those lines would be. Okay, then I can do my 0, so 0 times 12 would start up there. It's nothing, so I can pop that one on, but it still shows that I can go along 2 and down 1, or even from 12 up 1 and left 2. Then I'm looking at my pesky answers, so I'm going to be looking at 7, 9 and 11. So if I start from my 6, so my 6 times 12, I can then do 7 times 12, and I can add 2 and add 10, so 84, and you can see that pattern emerging again. And I can do the exact same with 9, so I can have my 8 times, adding 2 and going down 1, so you can see that pattern emerging there. I would be able to do exactly the same from my 12 times down here. I'm going up 1 group of 10, along 1 and along 2. And I wonder if you can work out what number that would be, because I popped it in that column, and hopefully you'll see that it's going down, ending in the digit 2, and it's 1 higher than my 140, that'd be 132 there. Okay, hopefully you can see those patterns, just a different way of showing you this same thing again. Okay, can you please pause the video here and have a go at answering these questions? I will then do the answers with you when you get back. Off you go. Okay, I hope you found those okay. Again, if you needed to use your building of it from the other day, that's absolutely fine, or from yesterday, but let's go through. So I've got 12 times 3. So if I know 1 times 12 is 12 and 2 times 12 is 24, I can add those together to give me 36. So if you had the answer 36, you can give yourself a tick. Next one, 12 times 5. So I'm going to work this out. If I know 10 times 12, or 12 times 10 was 120, and I halved it, that would give me the answer 60. So well done, and give yourselves a tick if you got that one right. Okay, 7 times 12. If I know 6 times 12, because I know 3 times up here, if I double that to get to my 6 times, which would be 72, I can add 1 more lot on, which would be 84. So again, it's just trying to use what we have. So if you've got 84, give yourself a tick. Last one, another pesky one. Something equals 12 times 11. So if I know 12 times 12 is 144, I can take 12 away. Or if I know 10 times 12 is 120, I can add 1 on. So I'm going to be adding 1 on for mine. And I know that 120, which was 10 times, add 12, is 132. So if you've got that answer, please give yourself a tick. Okay. How can we work these out then? So it says here to use the base 10 to build the 12 times table. So for example, the question it's given us here is 3 times 12, and what it's done is it's drawn them out 3 times. So you could add those up, and I know that 3 times 12 would be 36 because I can add those up. Can you have a go at completing these calculations? And you can pause the video first, and then we'll come back and do those answers. If you want to draw them out, that's absolutely fine. Or if you want to use the technique from the build it, you can do that as well. You don't have to draw them all out. Good luck. Okay, hopefully you had a good go at those. So 12 times 5, you could have either drawn them out or used your build it. So 12 times 5, I know that 12 times 10 was 120. I can halve it to get 60. Oh, and they've just tried to confuse us with the second one by swapping them around. Hopefully it didn't. So 5 times 12 is still 60. Okay, it's thrown in a division question. 48 divided by 12. How many 12s go into 48? So if I know 12, 24 doubled again, I'm using my double, so that would be 4. Okay, 84 divided by 12. How many 12s go into 84? So I'm thinking of the patterns that I know. 84, you could do your 12s and keep adding them up if you find that easier, or you can go to one of the ones that you know. So over here, we know that 5 times 12 is 60. How many more 12s? So the answer here would be 7. Okay, next row along, 12 times what is 120? That one's quite simple, being 10. 12 times what is 132? So if I know times 10 is 120, it's added one more lot of 12 on, so my answer will be 11. Okay, this time something divided by 12 is 8. So here I just need to do 8 times 12 to work out that answer. And up here I know that 7 times 12 was my 84. I need to add one more lot on, so I can do 84 add 12, which is 96. And finally, my something is equal to 9 times 12. So again, if I know that 10 times 12 is 120, I can take one lot of 12 away, which gives me 108. A huge well done if you got those right. Okay, fill in the gaps below. Something, 6.0, 7.2, something, something, and something. So hopefully those numbers are shouting out at you that you recognise them, but they have got decimal points in there now. So all of these numbers have been divided by 10. If we were to use our knowledge of our 12 times table and divide each of them by 12, or to pop that decimal point in the middle, hopefully you can have a go at working out the answers. So I'm going to ask you to pause again here and to have a go at that one. Okay, well done if you had a go at that. It looks quite tricky. It's not as tricky once you get started. So here, because it's still in the 12 times table, we know from up here that 5 times 12 would have been 60. So it's either asking you 0.5 times 12 or 5 times 1.2, but it's still using that knowledge. And then here, this would be our 6 times 12, and then divided by 10. So this one is going to be our 7 times 12. And we know from above up here that 7 times 12 was our 84, so we can pop our answer of 8.4. And then again, this one would be our 8, this one would be our 9, and going back, this one would be our 4. So 8 times, again, I can add 12 on or add 1.2 on. So this one would be 9.6. This one would be 10.8. And going down, minusing 1.2 from here, or taking away the 12 and then dividing that one, this one's going to be our 4.8. A huge well done if you were able to get those answers, because we haven't actually taught decimals, but our knowledge that we know from our decimals and our multiplication can work together quite well. Okay, our Emmet problem today. Emmet thinks that 12 times 9 is 98. Do you agree, and can you explain how you know? Okay, hopefully you can think about the ones that we know. So again, I always go back to the ones I know that are close to my number. So it's asking for 12 times 9, and I know quite easily that 12 times 10 is 120. So if I know that 12 times 10, I know that 12 times 9 is going to be that answer, take away one group of 12. So I can take away 12 up here and use that subtraction. Again, if we wanted to go from 8 and add up, that's fine. So I know that my answer is going to be 108. And Emmett's actually just 10 out, but he is incorrect. So you can then explain that I knew because I subtracted. And again, it's tricky for me to write, but hopefully you can see that that's trying to say subtracted there. Okay, your task for today then, you're going to have 5 do-it questions, very similar to the ones you did a few pages ago. You then have a Colin problem where he's got 12 times 8 is 86, and you need to explain why he is incorrect. And your Go Deeper is another one of these multiplication grids. So again, I'm going to really clearly pop these dark lines in both sides, and hopefully by now we know that whatever answer is at the top that we've multiplied across. So 5 times 7, first of all, that answer would go in this box. 8 ... 8 times by something is 96. What would that answer be up here? And then you've got 108, which we know is in the 12 times table. What could go up and across from those? Good luck on those. I'm going to ask you to pause the video here to have a go at those, and just make sure you come back for the learning pit at the end. Brilliant. Hopefully you had a go at those and you didn't find them too tricky. I'm going to be looking forward to seeing some of your work if you choose to send maths in today. But just before you finish and before you send in that work, just think about where you are on the learning pit today. Did you find the multiplication facts quite simple because you had your build it? Are you still finding them quite tricky? Are you all the way out of the learning pit today? Who knows? Can you please pop a learning pit on your work and send it over to us if you're sending your work in. A huge well done again for today, and I will see you next week for some more maths. Well done, and bye for now.